Hello and welcome back to Codeblaze, and I'm coming up with a video after a very long time. So in today's video we'll be just going over some of the practices that I do, and more specifically how I handle managers in Unity. So recently, I've created 5-7 games right now, but before that also I have quite some experience with C Sharp. So I decided to come up with a framework that would allow me to easily create managers, and I don't have to always create the singleton implementation myself, and there are a lot of problems also with the singleton implementation. So I just want to once define a proper way to create a singleton, and I wanted to reuse this. And the other thing is, as much like the more I use Unity, the more I want to make it event driven and use C sharp events more and more. So when creating singletons, the subscription part may become, because if one singleton needs to subscribe to another singleton, then there are issues with when the singleton will be created. So null pointer exceptions do arise. So to avoid that also, so I basically created a game framework, or you can call it a manager framework. So it's part of my Codeblaze utility library. So this is something that I talked about in one of my previous video, but I would go over this again in this video. So this library has some classes and functions that are basically ready to use as is, and they help you, like if I check this core folder, this contains some classes and extension functions which extend basic Unity functionality and provides us with some utility behavior, like this toast manager for Android. So I had a video regarding this also, on how to implement native toast in Android. So I have this class that you can use anywhere. Then I have some collections. So this is basically a simple collection for object pooling, and some other extension methods on colliders and transforms. So this with this you can always check if something collider is grounded or not. Okay, so that's what's there in the core folder. So the core folder basically extends the functionality of Unity. Then I have the extensions folder. So as in when I work with more extensions or plugins for Unity, and if I create some helping behavior, that goes there. So I have some code for Cinemachine, some for the Unity monetization, and some for UniRX. So this library will be developed as in when I develop games, or if anybody else also wants to contribute, it's there on GitHub. You can send a merge request. And then we have the template folders, which contain some basic behaviors for different types of games. So for now I have only top down, so I have two different types of top down controllers, some more mono behaviors for that. Then utils also contains some behaviors that you may use it in many different projects, like this is a screenshot mono behavior. So I basically use it whenever I have to take screenshots. And the main thing that I want to tackle in this video is the game framework. So the game framework is actually, it should be called manager framework. I may rename this, but it provides you with two manager base classes, the manager and the lazy manager. Now you can extend these classes to create your own managers, and they will by default be singleton and be initialized, and you can then use it anywhere in the code. Now there are a lot of arguments on the web that singletons are bad or something. Now that all depends on how you use them. So if you use them correctly, there's no point or no harm in it. So I would suggest, like, until you see a performance issue or there is a big issue, do try them. Like, you just can't remove singletons from our programming model, like Unity also internally uses them. So an example I have for this. Okay, now before I dive into the code, if you want to use this assembly or this library, you can get the Unity package file from GitHub, and then only thing you'll need to do is import it. So you'll get this plugins folder which contains this Codeblaze folder, and inside the scripts folder you'll have this assembly definition, and here you'll have this list of different extensions that this assembly can work with. So if you don't want UniRX stuff or Cinemachine stuff or TextMesh Pro, you can basically remove them and go in the extensions folder and remove the corresponding folder. Now I may improve this a bit in the future where you don't have to delete this folders and I can use a define symbol, but that's for later. But yeah, so that's basically how you just need to, it's pretty simple. You can just like using any other Unity package. Okay, so the manager system, as I said, starts with the manager class and it has an internal behavior, okay, which is this class. So this class is part of this behavior namespace. The internal behavior is something internal to this assembly only, so you won't be able to access it in your main game code. But this is something, this like the manager class works on top of this internal behavior class, so it gets the Unity events update and all, so that you have access to this events. So at runtime the manager will spawn a game object with the name of the manager, and you can see that in the hierarchy. So that's why this internal behavior is used. So you can see we have this virtual methods for most of the the ones that I use, the Unity events, so that you can override them in your manager and get access to that. Other than that, we have few other protected functions like instantiated child. So if you want to instantiate another game object inside the manager, or if you want to start a coroutine, so again this uses that internal behavior to do so. Okay, now to get this manager started, the first thing you'll need to do is extend a class from the scene controller. Okay, so the reason is this scene controller provides a abstract method called bootstrap, and here is where you'll do your manager initialization. Now the default execution order for the scene controller or any class that derives from it is set to -1200. So this will the start method will run pretty early, so you can be sure your managers are properly initialized. And the start method actually returns an enumerator, so this is an asynchronous start method, like it will go on multiple frames, so that if you have some pretty long initialization, you don't want your game to freeze up at start, that can be safely done here. So you just need to yield return on the different steps. And since this can take multiple frames, the other game objects update loop may have already been started before this start method has been called. That's why I have this on initialized event here, so your other behaviors can subscribe to this and we'll get how that works. So an example of this is this game controller, which derives from the scene controller. So this is the part of my game code, and I override the bootstrap method. So you can see I'm basically initializing one manager here, the tick manager. So the tick manager is kind of a pre-built manager that is currently there in the library, and this basically fires an event every second. So if you want to do some periodic stuff every second, you can use the tick manager to do it. Okay, and the way you initialize managers is basically called the initialize method for that type of manager in your bootstrap, and that will create the singleton object and everything. And you can see we have different, like I have some example yield returns here, so that also shows the asynchronous capabilities of that. Okay, now the thing is, in your other game objects, like I have this game behavior, I can't use the start method since this will be called before. So if I want to subscribe on the on tick method of the tick manager, I can't do that in the start because it won't be guaranteed if this manager has been created. And for that I use this on scene initialize method, which again comes from game behavior. So this is a another class that extends mono behavior, so it doesn't do anything basically. It subscribes to the scene controller's events. So this way, if you create your mono behaviors extending directly from game behavior, you already have access to the on initialized and on deinitialized events. So in deinitialize, event is fired before the managers are destroyed. So if you want to do some unsubscribing or cleanup, that you can do. And you can see this test game behavior, I'm using the my tick manager and I'm subscribing it, so this on tick method will be called. Now this does provide a formal way, so all I need to do is extend from manager to create my managers. So this is the tick manager, it extends from manager and it uses the on update method, so this is again overridden. Now I don't, and there is no need for me to have the singleton implementation right here, it will be handled by the manager framework. and then I have the game behavior class, which you can extend for any other mono behaviors that you want to create, so that it provides the on-scene initialized and deinitialized events. So that basically covers whole of the manager framework. And another thing you have is the lazy manager. So lazy manager is something that won't be initialized in the bootstrap but will be initialized when it is requested. So that is something, there can be use cases for that. And yeah, that's it. Now what would be the ideal use cases for such a framework? Because if you are creating a simple game, this could be a bit complicated for it, and I would say there's no use to do something like this. Or you can even create your own such kind of behaviors. Then the performance impact of this is, currently I haven't measured it since I'm also right now in the testing phase. I'm not fully satisfied with how this is implemented, and this is something that will improve over time. And the next thing is unreliability of this. So while testing, I have faced issues during the deinitialization phase. So if I run the first time, I get a null pointer exception. So let's just see how this manager framework actually works. I don't have anything in my scene, so everything would be in the console that's happening. So you can see we have the init phase, the final phase, and on initialize, and you can see the start method logs before everything. So this is the start method of my test behavior. That is why I need that on initialized function. Then in the test behavior, I have the on initialize. Here I can be sure my manager is initialized, and you can see the tick is happening. Now if I stop this, I get a null pointer exception, because I don't know why whenever I run it the first time, I get null pointer exception on during the deinitialization phase. Now if I run this again, I won't get it this time. So this could be something, the way I'm implementing it. And the deinitialization part, I don't think I'm fully convinced with how it is right now, but rest of the manager framework I'm pretty happy with. And the main idea of this video is basically I wanted to promote my game library that I'm creating, which contains utility stuff, and I would like others also to contribute to it, so that we can create a a robust Unity library that can help and reduce time for a lot of developers out there. So if you find this useful, please do check out the library. If you have any suggestions, and if you have features that you can contribute it, do raise a merge request for it. And thanks for watching, and subscribe for more content. I know I'm coming after a lot of months, but I have a few, one or two series planned, so that will be starting soon. Thanks, bye.